Hi everyone, my name is Jessica Perez, and today I'll be explaining Chapter 3, Problem 43 from the book. So the problem states, the three cables are used to support the 40-kilogram flower pot. Determine the force developed in each cable for the equilibrium. So first we identify our givens, and our given in this problem would be the mass of the flower pot, which is 40 kilograms. We are also given the lengths. So for the z-axis, we have 1.5 meters, the x-axis is 1.5 meters, and the y-axis is 2 meters. Then step 2 would be to find, and we are finding the force developed in each cable for equilibrium. Therefore, we have to assume that we're at equilibrium and that the x, y, and z components are going to be equal to 0. That then brings us to step 4, which is to make a plan. So step 1 would be to calculate the square root of the given lengths, or the magnitude. Then step 2 would be to determine the force related to the component and the length it is associated with. Step 3 is to set up a scalar equation of the components and set it equal to 0. And step 4 would be to calculate the force for each vector. That then brings us to step 5, which is to make a free body diagram. And in the diagram, we show the forces from point A. So force of AB is along the y-axis, force AD is along the z-axis, force AC is along the x-axis, and the force of gravity, which would be the weight times 9.18, is going down the z-axis. Also, in the free body diagram, I specified the lengths again. So for the z-axis, it's 1.5 meters, x-axis is also 1.5 meters, and the y-axis has 2 meters. That then brings us to step 6, which is calculating our solution. And so for the sum of components for force z-axis, it would be equal to 0 or for each component, it will be equal to 0 because they are at equilibrium. So you do all the components again, and the z-axis would be force AD multiplied by the height over the magnitude with minus the weight. So in this case, it would be FAD times 1.5 over the square root of 1.5 squared plus 2 squared plus 1.5 squared minus 40 times 9.8, and that would result with 763 newtons. We repeat the same process for the x, which would be FAC, minus the weight of FAD multiplied by the length over the magnitude, and that would result in a force AC equal to 392 newtons. And lastly, for the sum of forces for y, you do FAB minus the force of AD multiplied by the length over the magnitude, and that would result in force AB equal to 523 newtons. And those resulting forces are the answers. So thank you for following along and have a good day.